So I have question number 1.14, and the question says is what is meant by positive deviation and negative deviation from Raoult's law, and how is the sign delta H mix related to positive and negative deviation from Raoult's law, right? So first of all, let's see that what is Raoult's law. So Raoult's law states that the partial pressure exerted by a volatile component is directly proportional to the mole fraction of it in liquid phase, right? Let's understand it first, then we will go further. So first of all, this is your composition system, and here A and B is present, right? So if there is this is in liquid phase, then obviously they are going to be also present in the vapor phase. Like if there is water, you have also seen water present in atmosphere, right? So it happens always, that is corresponding to the how much amount of that component present in liquid phase. So obviously here in the gaseous phase, partial pressure of A is also got exerted by the molecules present in the gaseous phase, and partial pressure of B is also got exerted due to the molecules of component B present in the gaseous phase, and that is proportional to the mole fraction of A and B component, right? So PB is directly proportional to the mole fraction of B in the liquid phase, right? This is Raoult's law, and you don't have to confuse it with Henry's law. What Henry's law says is key, if you have any gaseous component that is present in your system, and if you increase the pressure of this gaseous component like CO2 in case of that carbonated drinks, if you increase the pressure of this gaseous CO2 gaseous phase, gaseous component, the how much you will going to increase the partial pressure in the system will define that how much that CO2 is going to dissolve. The gaseous CO2 is going to dissolve in the liquid phase. So how much that gaseous CO2 is going to dissolve in liquid phase, that what it says, Henry's law says, Henry's law, right? So it is for the gaseous component that got dissolved in the liquid phase, but here it is not the case. Here the case is ki the component present in liquid, how much is the amount of that component that confirms that this much pressure it is going to exert in the gaseous phase, right? So you have to make sure that the difference is clear to you. Okay, now let's read this statement again, that state that the partial pressure exerted by a volatile component is directly proportional to the mole fraction present in the liquid phase, right? And mathematically it is denoted as pi is equal to xi pi sat. And what is positive deviation and negative deviation? So first of all, read the positive deviation. When vapor pressure of a solution is higher than predicted by the Raoult's law, it is called positive deviation. So what happened, let's assume you have a component A and you have component B, right? And obviously the molecule is got attracted with each other, right? In A molecule like this, and in B molecule like this, the BB molecule are together in forming bond like H bond or any bond, van der Waals bond, any bond, right? And if you going to mix this, it will going to form a mixture of solution A and B, right? Solution A and B, right? Now the bond is A B A B, right? So A bond got break, BB bond got break, and they will form AB AB AB, right? So obviously if this bond is going to be stronger than this, that means it is getting more stability, these molecules are getting more stability. And if this bond is very attractive to each other, that means the ability to vaporize that A and B in the atmosphere of this jar, it is the probability is going to be less than usual, right? So suppose the partial pressure here is 1 bar and the partial pressure of here is 1 bar, so obviously by calculation it must be 2 bar, right? But we have seen that in positive deviation it becomes 2.1 bar. So how, why this pressure has increased? Because that in the positive deviation what happens is they have formed AB is weaker, they have formed weaker bond than and BB, right? So that means what happened ki it will easily got vaporized in the gaseous phase, right? So that will increase the pressure, more pressure than the calculation, right? So that is the case. So once you have cleared this concept, you can also know the positive deviation, what is happening in positive negative deviation, sorry, right? So simple thing. So now you can understand by reading this key the vapor pressure of the solution is higher than predicted by Raoult's law, right? We have predicted that it is going to be 2 bar, but now it is 2.1 bar because the bond AB is got weaker than AA and BB. So that's why the A has the more tendency to get vaporized in the vapor phase than we have predicted, right? Simple. And reason is the attractive force between the unlike molecules AB is weaker than AA and BB, and molecules escape easily in the vapor phase, and that's why partial pressure increases, and delta H mix is greater than 0 endothermic because the bond ultimate bond that is going to form is weaker than the previous bond. That means energy is needed and it is not forming a stable bond, right? More stable bond. So example is ethone and ethanol and acetone. Simple. And after that, negative deviation, the opposite of that, vapor pressure is going to be lower than predicted by Raoult's law. And reason is they will going to form AB bond that is going to form is more stronger than the bonds like bonded A and BB, right? And the molecules are not able to escape easily in the vapor phase. That's why the vapor pressure is going to reduce, and the delta H mixture is less than 0 exothermic. That means energy is released. That means a stable bond is going to be formed, right? So the example is chloroform and acetone. So this is very simple. In positive deviation, the vapor of the solution become higher than the predicted value by Raoult's law. In the negative deviation, the vapor pressure get lower than the predicted by Raoult's law, right? So this is the thing. It is very easy. Once you understand the concept, you can write it by your own, and simple.